So we're going to take 2 days on this. This is the first part of section 3.3, slopes and graphs of linear equations. So in Algebra 1, you guys spent weeks on looking at linear equations. You looked at 3 different formulas: slope-intercept form, point-slope form, standard form. You looked at what slope was, what y-intercepts are, what x-intercepts are. We spent a lot of time. This is basically just like a little refresher course on this section, and hopefully all this stuff comes back into memory. You'll understand this pretty well. So a linear line is a straight line. Every straight line has a couple things about it. So it has a slope. The slope is how steep that line is. So lines are everywhere in the world, and there are some lines that are steeper than others. Some lines have no steepness at all. They're completely flat. Some lines are so steep that we can't even put a number to it because they're vertical. But most of the lines that we're going to be dealing with in this class will be lines that are either increasing or decreasing at a certain steepness. And the way we determine what the slope is by finding the 2 points and using this formula, y2 minus y1 over x2 minus x1, to find the rise over the run. The rise over the run is a fraction relating how far the line is going up or down versus how far it's going left or right. Slopes are usually in fraction form. If you ever get an improper fraction like 5/3, leave it as 5/3. Don't put it into a mixed number. If you ever get a whole number or an integer as your answer, like -4 as your slope, every slope technically is a fraction, so if you ever get an integer or a whole number, you would just put a 1 underneath of it if you went to graph it, but you don't need it if it doesn't have it. But usually the way that the points work out, a lot of times they're just plain old fractions, like the slope of 2/3. You would just always leave it in fraction form, never decimals or anything like that. So the slope formula kind of looks similar to the distance formula. The slope formula is right here. I'm just going to write it again so we can get used to seeing it. For some reason, way back whenever someone created slope, some mathematician, they decided to use the variable m to represent slope instead of s. Not sure why. But m stands for slope. Whenever you see that, that means slope. And the slope formula is y2 minus y1 over x2 minus x1. It looks similar to the distance formula in that you're using these little y's with the 2's and x's with the 2's and the 1's. Yes?
Are you going to have like formulas?
Yeah, I plan on having all the formulas just to make life a little bit easier for everybody. Yes. So the question was, are there going to be formulas like there on the test for you? And the answer is yes. I'll make sure that you guys have the formulas so you don't have to stress about memorizing them all. At this point in life, I think that it's okay that I gave you the formulas. So here is the formula. It's just taking the y values of the points and finding the difference of them. The difference of two numbers finds out how far apart they are from each other. When you're finding how far apart the y's are, that's determining the rise. That means how far up or down that line is going. When you're finding the difference of the x numbers, the x numbers are here. You're looking from left to right. The x numbers difference is representing the run. How far left or right that line is going. When you put this into the formula and you divide these two differences, they create a ratio, and the ratio is comparing how far it's going up or down versus how far it's going left or right. That's what rise over run is. It's a fraction comparing the steepness of each line. To find the slope of the line, I could give you an actual graph, and I would say find the slope of the graph. I could give you 2 points and say find the slope of these 2 points. You could always use the formula. If you like to find the slope using the graph, you could just actually count and see how far it goes up versus how far it goes over. If you have points, you're going to want to use the formula because most likely I'm not going to give you graph paper to graph it and then count. Whenever you're going up, that is a positive movement. So if you think of a number line, if we had a vertical number line, the numbers above would be going up. The numbers below 0 would be negative going down. So whenever you are moving up on a line, like to get from this point to that point, you're going up, that would be a positive rise movement. Whenever you're going down, if the line was a negative slope, if you're going down, that would be a negative movement. So that means your rise would be negative. Whenever you're moving to the right, so if you think about a number line that's horizontal. All the numbers to the right of 0 are positive. Whenever you're moving to the right, that's considered a positive run movement. Whenever you're moving to the left, that's considered a negative run movement. So, finding the slope of the lines that passes through each pair of points. Let's do these two together. So, letter A. This is the first order pair, 1, 2. This is the second order pair, 4, 5. This is an X number. This is a Y number. Because it's the first ordered pair, I'm going to label this X1 and Y1. This is the second ordered pair. This is still an X number. This is still a Y number. Because it's the second ordered pair, I'm going to call this X2 and Y2. You don't have to take the time to label these, but if you do label them, then the formula is nice and simple. You just follow where the numbers go by looking at what you just called each number. The formula says take Y2 and subtract Y1. Well, I like to show all of my work so I don't make a mistake. Y2 is 5, so my numerator is going to be 5 minus Y1 is 2, so it's going to be 5 minus 2 on the top. The denominator, X2 minus X1. X2 is 4 minus X1 is 1. So that is the little work that I would show to find my slope. The more work you show, the better. I know that right now we're in not a traditional math class where you would show everything on a piece of paper that I would give you and then hand it back. So it's really important that when you guys take these online tests that you do upload your work so I can see if it's a 4-point question, if I should only take off a half of a point or a whole point or all 4 depending on how wrong it was. Sure. Well, 5 minus 2 is 3. 4 minus 1 is 3. So we get here that our slope is 3 over 3. I would just simplify that to be 1. That means that this slope is 1 or 1 over 1. That means the rise is 1. To get from one point to the next, you would go just up 1. And you would then have to go over 1, up 1, over 1 for this. So if we were to just sketch this really quick on the side so you can see. 1, 2, I'm just going to make this sketch. 1, 2 would be here, and 4, 5. 2, 3, 4, 3, 4 would be here. So if I was to look at this line, to get from one point to the next, I go up 1, over 1, up 1, over 1, up 1, over 1. So this slope is 1, meaning that to get from one point to the next would just be up 1, over 1. Not all of them will work out to be like that. Most of them will be in fraction form, but whenever you get a whole number like that, please realize that there is always an invisible 1 underneath of that answer, because for every slope, you need not only a rise, but you also need a run. Using the formula again, if it's helpful for you to label these each time, please just take a couple of seconds to do that. If you don't need to label it and you can just follow the formula without doing that, that's fine. You're basically just taking the second y value and subtracting the first. 1 minus 4 will be the numerator, the denominator 2 minus negative 1. Be careful when you're subtracting negatives because you don't want to make a mistake and just leave it as 2 minus 1. 2 minus negative 1 really will be 2 plus 1. So when I simplify this, 1 minus 4 is negative 3. 2 plus 1 is 3. This slope is actually negative 1. So slopes can be positive, they can be negative, and there's 2 other things it can be as well. Alright, so what I want you guys to do is try the next 2. The next 2 problems, the answers are going to be different, so they're going to be a little bit weird. But I do want you to try these 2. I'll give you a couple minutes to try them, and then we'll go over them as a group. right, let's go over these. If you didn't have time, it's okay. Just follow along and double check your work. Make sure you don't make any mistakes here. So, like I said, something weird is going to happen in both of these. There are 4 types of slopes, and after we go over these, we'll talk about all 4. So, to find the slope of these lines, I know that the formula says take the second y and subtract the first y. So my numerator will be 4 minus 4. My denominator says take the second x, subtract the first x. That's 3 minus 1. Then I would simplify this. 4 minus 4 is 0. 3 minus 1 is 2. So I'm left with 0 divided by 2. Well, if you put this in your calculator, you should know this at this point, but if you put this in your calculator, 0 divided by 2 is 0. You can take nothing and divide it into 2 parts, which is nothing in both parts. This slope is 0. So it is possible for you to get a 0 slope. A 0 slope means the line of this, the steepness of this line is 0, meaning that it's flat. There is no incline, there's no decline, it's just a flat line. Like when we're walking around school, all of these floors we're walking on are slopes that have 0, there are lines that have 0 slopes because you're not going up or down on an incline. There might be like an incline down there. Maybe the catwalk's a little bit of an incline, but for the most part, yeah, there's a couple ramps, but and we could find those slopes potentially if we took a measuring tape and measured the rise over the run. But for the most part, when you're walking around, you're walking on flat ground in school, and that would be a 0 slope. The other thing that can happen as well is when 2 points have this type of situation. When I go to subtract the y's, this is 3 minus 1 divided by the x's, 3 minus 3. Well, 3 minus 1 is 2, 3 minus 3 is 0. This is the opposite. Now the 0 is in the denominator. If you are to take this 2 and divide it by 0, your calculator will tell you that there's an error. There's a domain error. Yes? Yes. So it's the opposite of being a horizontal line, which has no steepness. This is a vertical line, and vertical lines slopes are called undefined slopes. When you have a vertical line, you can't put a number to that steepness. Like as a line increases in steepness, it gets higher and higher and higher like this because the rise is getting larger than the run by so much. Then all of a sudden, you get to a vertical line, and that's like the tipping point. Your calculator can't understand this because it can't take a number and divide it into nothing. So you can't ever divide by 0 because every time you're dividing, you're taking that numerator and separating it into how many parts there are in the denominator. Well, you can't take 2 things and then divide it by nothing because that would be like almost like magic. You can't like make them go away. So that's what your calculator does, and it doesn't understand that. That's why it's called undefined. And here's what these slopes look like. Maybe this will make more sense. If I was to just sketch these graphs real quick on the side, 1, 4 would be over to the right 1, 1, 2, 3, 4 would be this point here, and 3, 4 would be this point here. So I can see that this makes sense. The slope is 0. This is a flat horizontal line like that. It makes sense that slope is 0 because it's a flat line. There's no steepness. However, this line here, if I was to graph this one, 3, 1 would be here, and 3, 3 would be here. Well, this is not perfect. But if it was, you would see that this is a vertical line, and this steepness is undefined. I can't even put a number to it because the calculator doesn't understand it because it's vertical. So the 4 types of slopes we have are either positive slopes. Positive slopes are when these slopes, this M here stands for slope, when the slopes are greater than 0. So I knew that this first example here, since it was a positive number, that is a positive slope. Positive slopes increase from left to right. This example right here, this has a positive slope because it's increasing from left to right. A line with a negative slope is when the value of M is less than 0. So the second example is -1 here. That would be a negative slope because it's a negative number. Any negative numbers will have a negative slope, meaning that it will decrease from left to right. A 0 slope is a horizontal line. The slope is exactly 0. A line with an undefined slope, it will be a vertical line. Does anyone have any questions on that? All right, moving on to the next part. Let me clear this and scroll down. The question says, sketch the line 2x plus 3y equals 6. Then find the slope of the line. It says, choose two different pairs of points on the line and show that that same slope is obtained from either pair. So, if I gave you an equation, 2x plus 3y equals 6, and I said graph this, there's honestly many different ways you could graph this line. You could put it into slope-intercept form and graph it. You could graph it by hand by finding points that are on the line. You can put it in your calculator into the y equals screen and get a table and then graph that. You could find where this line crosses the x and y intercept and graph those points. I mean, there's like a lot of different avenues you can take to get to the same exact result, which is just graph this line. So it says to find the slope of the line and graph it. So my brain is thinking, if it wants me to find the slope of the line, then I might want to take this equation and put it into a form that shows the slope. So last year when you guys were in Algebra, or 2 years ago, whenever you took Algebra 1, you learned 3 different formulas. One of the formulas looked like this, y equals mx plus b. And this formula is called the slope-intercept formula. If you guys could write this down, please. This is the slope-intercept formula. And this formula gives you two things. And it's in the name. It gives you the slope, and it gives you the y-intercept. And again, the reasoning behind the variables they chose to represent slope and y-intercept, not really sure, but this formula is basically just solved for y. Any equation we deal with in this section will have two variables, x and y, but when you are solved for y, that equation that you have will be the slope-intercept formula. So I could take this equation, which is actually in standard form if you remember that, and I could solve this thing for y. So all I'm going to do is use the opposite of the order of operations like we did previously in chapter 2, move things around and just solve this thing for y. To do that, I would move this 2x first. How would I move that to the other side? Ava? Yeah. Well, we're going to move this to the other side. So because this is a positive, I would what? Yes. Because it's a positive, I'm going to subtract it. So when I subtract the 2x from both sides, these are going to go away. And on the left-hand side, I'm left with 3y here. Now, the right-hand side says 6 minus 2x. Those things are not like terms. We know that. And you could write 6 minus 2x the way that it is, but the math brain in me wants to flip it. And the reason why is because the formula says the slope first, which is the number with the x, and then the y-intercept, which is the plane number. This is the plane number. This is the number with x. See how the formula has the number with x first? That makes me want to put this number first. This is a negative 2x, and I know that because see this sign right here? I know that it says we subtracted, so it says minus 2x. And a minus sign is a little bit longer than a negative, but it does the same thing. It brings the number to the same direction to the left. I'm going to rewrite this as negative 2x. And this is a positive 6, so I'm going to write 6 like this. This says 6 minus 2x. This says negative 2x plus 6. This is a positive 6. This is a negative 2x. This is a negative 2x. This is a positive 6. It's the same thing. See how it's just flipped? See some nods? Yes, we're good? Okay. What's the last thing we would do to solve for y? I have a 3 there. I don't want the 3 there. I want just a y. What would I do to solve? You don't want me to start calling names out, do you? Mike? Yeah, divide by what? Yeah, so I'm going to divide everything by 3. When I divide by 3, these go away, and every little term on the right-hand side will get divided by 3. So I'm going to divide negative 2x by 3. This is going to be negative 2 thirds times x. And I just pull the negative 2 thirds out of it and put the x on the side so that I can see that the slope is negative 2 thirds. And then 6 divided by 3 is 2. Once you have this thing solved for y, then you can start graphing. Now, if you remember back to Algebra 1, we know here that this is your y-intercept, this plane number. So looking at the formula, this number here is the y-intercept. That's where it crosses the y-axis. So where does this line cross the y-axis at? 2, yes. And then this number here, this is the slope. The slope tells you what to do to get to the next point. First of all, is this line going to be a positive line or a negative line? Negative, because it's a negative slope here, right? And the slope is going to tell you 2 directions. It's going to tell you to go down 2 and to the right 3. Now, some of you might be thinking, well, I have a graphing calculator. I can easily do this without having to do a ton of math. And if you can solve for y, then yeah, I would, if I were you, use your calculator. Let me show you how you would do that. You would open up your calculator, and you would go to the y equals screen. Erase whatever is in there. If you have a graphing calculator, please get this out and follow along with me. If not, then I'm also going to show you by hand how to do this. So in the y equals screen, you're going to use a parenthesis around the slope. And I would always do this anytime you have a fraction or things can get messed up. So do parenthesis, -2 divided by 3, close that parenthesis, and then x plus 2. So this is going to be the equation that we're going to graph by hand, but now it's going to be in the graphing calculator. To get to a table of values, you would hit second graph. To get to just the graph, you would hit graph. Let me just show you what the graph looks like. So when I hit graph, here's what it looks like if your window is set up right. If your window is messed up, then I can help you show you what buttons to push to make this better. But here's what the graph looks like. It's negative, I can tell, because from looking left to right, it's going down. And I can see a couple of things. I can see the y-intercept being 2, but I can't really see the slope that well. The graph function on the TI-84 is great in that you can see some things, but some things are not necessarily perfect. Like I wouldn't be able to tell what the slope is from here because things aren't numbered and stuff. So to get to the actual points, you would just hit second graph, and you could see some points you could use to plot. So you could plot some of these points here if I asked you to graph this equation. Looking here at the graphing calculator table, the numbers are the same here as the table that's already given. You can see -3. Well, I have to scroll to get to that one. So you can see -3 is going to be the same. It's going to be the +4 here, 0, 2, and so on. You only need 2 points to plot a line. So it's up to you what 2 points you can use. If you don't have a graphing calculator and I said to graph this thing, here's what you would do. Starting at your y-intercept, I'm just going to just draw a sketch. If I ever ask you to draw a graph and you don't have a graph, here's how you would do that. You would go to 2 on the y-axis and make a point, and that's because that's your y-intercept. Your slope is -2/3. The slope tells you what directions to go, up or down first, then left or right first. This is a -2. When you're rising a negative, that means you're going to be going down. When you have a positive x number, that's going to the right. So if you think about a number line, going up, or like maybe something simple that you could understand better, like an elevator. If you're going up on an elevator, that would represent a positive movement in math. If you're going down an elevator, that would be a negative movement. So like if you started at the 8th floor and you're going down, you would maybe go to like the 5th floor. That's going to decrease. Same thing happens with the slope. Going up would be a positive movement, going down would be a negative movement. What about on the x-axis, so a horizontal line? What do you think going to the left would be? What type of movement? Positive or negative? Going to the left. Yeah, negative. And then positive would be to the right. So we're going to go down 2 to the right 3. So down 2, 1, 2 to the right 3, and it would land right here. Okay? Any questions on that? Some of us look very sleepy for Monday morning. I get it. We okay, though? We do have a test on Friday. I want to make sure everyone's okay before we move on. We're okay? Everyone at home, are you all okay? All right, so what I want you to do, is that it for that page? Flip this over to the other side. We're going to try one. Let's see if we're going to try it on our own or together. I'm not sure yet. Let me see. All right, so real quick. Slope-intercept form, I already pretty much went over this. It's the formula y equals mx plus b. You basically just solve the equation for y. So I think at this point we should be ready to do this on our own. So the equation that we have here is 4x minus 5y equals 15. I want you to graph this equation. In order to graph this equation, you first have to put it into slope-intercept form. To do that, you solve for what variable? Y. So take this and solve for y. After you solve for y, you then have two options. You can either put it into your calculator and get the table of values from there. If you don't have a calculator, then you can graph it by plotting the y-intercept and using the slope to get to the next point. So I'm going to give you guys a couple minutes. For everyone here, if you wanted to work together from your desks, that's fine. If you would prefer to just work alone, that's fine. And please ask me questions as you have them. And everyone at home, in a couple minutes, we'll go over these together as a group. So that one, the zero you're talking about is the y-intercept. So that means that one would start at the origin at the center. But that slope is 2 over 1. What you did was right. That is the slope, 2 over 1. Yes, exactly. Yep. So you can start the y-intercept right in that little start of the y-intercept. Be careful. Still to the next one. Give it 5 by negative 5. Oh, you're done. So this is going to be 5. Yeah. And then this is going to be, yeah. So instead of starting at a positive 3, we'll do a negative 3. And it's on the y-axis. Alright, everyone's great, awesome. So now to graph it, you have two options. You want to do it by hand, you want to do it in calculator. Alright, put y equals. Alright, so hit the left parenthesis above the 8, hit 4 divided by 5, hit the right parenthesis above the 9, x. And then minus 3. Hit second. And then to get to the points to graph this, I would choose ones that are nice and easy, like 0, negative 3. And then 5, 1. And all you need is 2 points to graph it. 2 easy ones, yeah, that aren't decimals, and that's it. I'll be right there, Mark.
Wait, I grabbed this one.
You can graph both, yeah, you're ahead.
So like this.
So you're graphing them both in the same graph. So this one looks good, you started at negative 3, went up 2 over 1.
Yeah, that's it. So
There's 2 of these for both lines.
Yeah. Yeah, there you go. You're right. All right, because of time, I want to make sure we can go over these answers before we leave class today. So I know some of you are moving ahead, which is great. Come back with us, make sure that your answer is correct for this one, and then we'll call it a day. So we're going to solve this thing for y. To do that, we would subtract 4x from both sides. When I subtract that, be very careful. You are left with a negative 5y on this left-hand side. That minus sign is attached to the 5y. And then on the right-hand side, my brain is going to put the negative 4x first plus 15 because that's the correct way that the formula gives us our slope with the number with the x first and then the y-intercept. What number am I going to divide everything by? All right? Yes, we're going to divide everything by a negative 5 because the negative 5 there has to go away. Not just the 5, the negative sign does as well. When I do that, I'm left with y equals negative 4 divided by negative 5 is a positive 4 over 5. So this is 4/5 x. And then 15 divided by negative 5 is negative 3. At this point, the class might be breaking up into 2 different methods. Some of you might be doing it by hand. Some of you might use your calculator. It's up to you. Both will get you the right answer. If you do this by hand, You graph this number on the y-axis. So you go to the 0, 0 and go down 3. 1, 2, 3. You plot the point. Then you use your slope. 4/5 means go up 4 to the right 5 from here. 1, 2, 3, 4. 1, 2, 3, 4, 5. All you need are 2 points to plot a line. After you have your 2 points, there's your line, and you're done. If you use your calculator, you would put it into y equals, go to the second graph, find 2 nice easy points you can plot, and then all you need is 2 points to have a line. So to just recap, WebAssign 3.3 is due Thursday. You should be able to start some of the questions now, but some of them we're going to be doing tomorrow with parallel and perpendicular lines. So if you wanted to just wait till tomorrow's lesson, that's fine as well. We have a quiz on Friday. Please check your grades for anything that's not accurate, anything that I still need to put in. If you finish something late, please let me know. When the bell rings, everybody here, you're free to go. Everyone at home, you guys can go now. I'll see you tomorrow. Sage, do you have a question? Alrighty, guys, I'll see you tomorrow. Ava, can I talk to you real quick? Did you get my email back?
Yeah, I did.
Okay.
Thank you for answering so fast.
Yeah. Oh, like when I read it on Sunday, I was like, oh no, I don't want you to be struggling. I never want you to. So just send me an email right away. Because what it is probably something simple, like the WebAssign wanting you to answer a certain way. And it's so frustrating when like you can't figure out what they actually want because you could still be right. It's just the way they're answering.
Yeah, that's how I figure it out.
So for that one, just forget about it. But moving forward, like because we now have another one. I don't want you to like feel like each time you do this, you're setting yourself up for failure. You know, because that then when you do get it wrong, you're gonna just get upset.
Yeah.
So if something's happening, like you tried it, you hit the read it, and you still don't understand, tell me what question number it is. Send a screenshot so that I can help you with what the question is. Like, and I can either make a video or I'll do the notes and send you a picture back of my answer so that you can kind of compare it. Okay?
Yeah, that sounds great. I really appreciate it.
Yeah.
Okay, thank
Yeah.
you so much.
Yeah. Good luck with it. I hope it's not that bad.
Yeah, I don't think it will be. I remember doing this like what we're doing now.
Okay.
It's all coming back.
Okay. Good.
Thank you.
Yep. See you tomorrow. Hello. What period is this? 7? Hi, Vince. Did you get my email about going to a different room today? Say that again?
Yeah, I forgot.
It's okay.
Sorry.
It's fine. Hi, Miles. Did you get my email about going to a different room today?
Yeah, I was a little confused. What room am I supposed to go to?
So let me send you the link through the chat so it's easy for you to find, okay?
Thank you.
Uh-huh.
Are you still going to be the one who's instructing it, or are we having a different person instruct it?
It's going to be somebody else, actually, because it's hard for me to help everybody at the same time. So her name's Mrs. Constantine, and she'll be instructing it, and she'll tell you exactly what to do for the test. Let me open up the chat. This is the link to click. So copy and paste that. Leave this one, then copy and paste it, and then get into that one, okay?
Okay. Got it. Thank you.
Yep. how are you?
Good.
Nick, once everybody gets here, I'm going to set everyone up, and then I'm going to eventually let you guys go off and work on your own, but just stay in class until I tell you that, okay?
Okay.